Alright, so today we're going to be talking about momentum, and our first objective is defining impulse and momentum. So what is momentum in the first place? Well, momentum is the property that moving object has due to its mass and its motion. So we see here this cruiser, which weighs 4,179,637,541 kilograms. It's got a mass, okay, that big number. And then its its motion is 8,000 miles per second. Not fake numbers. These are all estimations to the Halo community, or from the Halo community. So yeah, that's pretty heavy and that's pretty fast. And since it's got a mass and it's moving in motion, it will have a momentum. Now, in order to find the momentum, we have to multiply the mass times the velocity of motion. So 4,479,637,541 kilograms multiplied by 8,000 miles per second. That's a big number, 4 billion. So let me do that. So we have 4,179,637 multiplied by 541. Or I'm sorry, 541 multiplied by 8,000. That would equal 4,796,37,541. Right? Times 1,000. Number I get, or the momentum of the Halo 4 Infinity Cruiser, would be 3, what is that, 4, 3, 7, 1, 2, 0, 3, 2, 8, 3, comma, comma, comma. I'm not going to say that number. Right? 100,000. 100,000, 10,000, 100,000. Million, 10 million, 100 million, billion, 10 billion, 100 billion, trillion. 33 trillion, 437 billion, 100 million, 320,000. What's the momentum's kg or kilograms times ms. So that's its momentum. Wow, quite a big number. So that's momentum. Now for impulse. So for impulse, we can go back to that tank example, and basically when the tanks collide, let's say the Hellcat and the ALC, when the Hellcat and the ALC collide, the Hellcat's energy is transferred into the ALC, and the ALC's energy is transferred into the Hellcat. So there's your impulse. So, after impulse and momentum, this brings us to number 2, which is defining conservation of momentum. How is momentum conserved? Well, one good example is where me and my classmates run into each other with the exercise balls, okay? What happens is we run into each other, and then the elastic balls bounces off, or the extra balls bounces away, meaning the energy is conserved because we're bouncing backwards, or going backwards after the impact, the collision. So let me bring that example up here. And in another example, I take a basketball and a tennis ball and put it on top of each other. Now when I let it drop, the tennis ball is going to follow the basketball, and as soon as it hits the ground, they're both going to fly away from each other, which is also having energy conserved. However, the tennis ball is going to go further and higher and faster because obviously it's a smaller mass, hence the basketball being a bigger mass and shooting it away, shooting the tennis ball away. So that's conservation of momentum. And now we go to elastic collisions. Alright, so in this game, I actually found out that you can show elastic collisions where kinetic energy is conserved, because when I hit somebody, they're gonna bounce off. So I have a zoomer of heavy mass one, and I'm gonna find an equal one. These are all small ones. Here's a bigger one. So if I ram into him, we both bounce off. We don't crash and get really... With the smaller one, he also kind of bounces off, but with a little bit more. I'll have better examples. I'm just trying to have some fun with this. Yeah, they bounce off. Oh, here's a good example here. Or if I take a smaller one and hit him. Okay, not like that. Wish there was two-player, this would be easier. I like this guy here. We both bounce off. Elastic. Same with the... Okay, that didn't work. You get it. Simple. Yeah, we bounce off. Elastic. So that's that. This is on my phone camera because, I mean, the real one's not really. Yeah, no, it's just the battery's dead. Yeah, and if I continue, I'm gonna probably blow up. So I'm not gonna continue. So that was that. What's going on over here? Some kind of war. Actually, can I show anything with my weapon a little bit? I don't think there is anything. Ricochets? Oh, there is a ricocheting weapon. Yeah, shoot the wall, and it bounces off. That's elastic. Elastic, yeah. Hit that guy, and it just keeps going. See, it just keeps bouncing off. So there's that. Double kill. Triple. It's funny, I mean, the bullets just keep bouncing off. Yep. They don't lose any energy as they bounce off, they keep going at the same. Right. I think that's a fixed. I think it's fixed property to be able to bounce off at exactly the same. And they just keep going.
Without losing speed.
Right.
Fixed,
right, it's fixed, but it shows how the bullet keeps going with elastic. Here's inelastic. This one here, it just kind of dies. Yeah. So there's that. I'm not letting you kill me. Oh, that's not what I want to do. That was random. So yeah, that's it. I'll have better examples. I just want to have some fun examples. You guys can't hit me, I'm in a shield. And bouncing off. Hey, that's... And that's elastic as well. He just keeps bouncing off me. They touch me and just keep bouncing off. I don't know if that's a good example either, but whatever. It worked. Alright, time for better examples. Be back.
Go! Oh, they were better prepared. Ready, go! Oh, God. Oh! Here, man.
Go! Hey guys, so here's an example of, what's it called? Oh shoot. Where, you know when things collide, the momentum? I can't believe I forgot. I was just talking about it a few minutes ago. Anyway, here's an example of that in World of Tanks. Wow, I'm so scared. Inelastic collisions. There we go. Inelastic collision? Or inelastic momentum. I forgot, I'll make a little annotation. Oh, I can't believe I forgot a little derp there. But, so, we have basically my tank, IS-3, heavy, and Striker's tank, M103, American, heavy, mine's Russian. And we're gonna collide. Heavy, heavy. Obviously, the force of the collision is gonna be the same. Boom. But wait, that's not all. He's actually moving me because the power of the M103 is stronger. So... the power of the M103's engine is stronger. It's for the correction. And yeah, so you can see he's moving me basically. And that's funny. So that's heavy on heavy. Alright, now let me get a light on light. Same collision. Up a bit. Alright. Oh, that's right, we missed each other the first run. There he is. So let's collide right here. So light on light. So, and my engine is stronger now. The power of my engine is stronger to push him. It's pushing him 5 kilometers an hour. So there's that. And now let me get the third one started. Now, the third one, light on heavy collision. So an example, this is like, oh, it's not just here, but it's like, let's say a small car on a truck. You know, how like that's a small car conquers a truck. Conquer is actually a heavy collision. Or not heavy, not that heavy, just heavy. So what's gonna happen? It's either going to be A, I'm going to ram him, we're going to ram each other, collide. I'm going to damage him, and he's going to damage me, and I survive. Or B, I'm going to ram him, he's going to ram me, he blows up without me being damaged at all. C, he's going to hit me, and I'm gone. And correct answer is C. I'm gone. His mass is just way too much for my tank to handle. His speed was slow, mine was fast, it just completely demolished me. So those are your... What was my... So that's your inelastic collision. Yeah, I read off of my iPad when I was doing these. So that was inelastic collisions. I also showed elastic collisions, which are bouncy. This one's going to be after elastic. This one's number 4. So yeah, that's about it. Other objectives I'm gonna post, so yeah, that's it. Thanks for watching.